At the very beginning of the universe, particles had no mass. But less than a picosecond after the Big Bang, something happened, and those particles started to gain their masses. And after that, the whole universe, and eventually life itself, began to emerge. It was a fundamental field that was responsible for this something, and the field was associated with the Higgs boson. The Higgs boson is a wave in the Higgs field, just like the light waves in an electromagnetic field. Particles interact with the Higgs field to get their mass. In order to get heavier mass, particles need to interact with the Higgs field more. The Higgs boson is named after British theoretical physicist Peter Higgs. He published a paper in 1964 along with Brout and Engler, explaining the Brout-Engler-Higgs mechanism in which a scalar field gives particles mass. In elementary particle physics, we have an established theory that provides a complete description of the particles and their interactions, and it is called the Standard Model. The Standard Model has been very successful in providing accurate predictions for essentially all particle physics experiments carried out so far. Since it was proposed in 1964, the Higgs boson has remained the final missing particle of the Standard Model. Any proof that the Higgs field did not exist implies that the Standard Model was incorrect. The Higgs boson can be created in a particle collision, and once produced, decays to the heaviest allowed elementary particle that can be detected in particle detectors. But our particle collision technology was not good enough to detect these particles, and we had to wait until 2008 for Cern to build the Large Hadron Collider, which is the world's largest and most powerful particle accelerator. And LHCb, ALICE, ATLAS, and CMS were the four big particle detectors, and at last, in July 2012, ATLAS and CMS scientists announced that the Higgs boson has been observed. At this energy level, the Higgs boson decays dominantly into a bottom quark and its antiquark. This channel experimentally is very difficult to observe. In fact, the discovery comes through the gamma-gamma decay. Just after this experiment, the CMS collaboration published a paper. The group was announcing their discovery as follows. The decay of 2 photons indicated that the new particle is a boson with a spin different from 1. The results presented here are consistent, within uncertainties, with expectations for the Standard Model Higgs boson.